When most people think about CSS, they think of it as just a bunch of properties that you can apply to a certain group of elements, right? But there's a lot more under the surface, and CSS contains many things that are essentially hidden, and stuff interact together in weird ways. So today, instead of specific tricks, I'll be doing a deep dive into 5 simple things that are actually more complex than they seem. So units are pretty simple. There's two main types, absolute units and relative ones. Absolute units are constant and don't change depending on anything. They include the commonly used pix for pixels, but there's also cm for centimeters, pt for point, and a bunch more, which are all different units of length. But you can't only use these because web pages need to resize nicely, which is why relative units exist. The most commonly used one is %, which is relative to the parent element. For example, with 50% fills half the container. But you also have to know that there's times where % means different things, such as when using the transform property, % doesn't refer to the parent element but itself instead. This is because % isn't just a unit of length, it's a percentage, which means different things depending on what makes sense. The font size property can also accept %, which changes the font based on the current font size. Another one is em, which is simply the font size of the element. Use this when you want the dimensions of something to be dependent on the size of the font. For example, you might set the height of a navbar to be 3 em, which means the height will expand automatically if the font size increases. The next set is VW, VH, Vmin, and Vmax. Each of these refers to 1% of the dimensions of viewport, or the entire page. VW, which stands for viewport width, is 1% of the page width. VH, viewport height, is 1% of the page height. Vmin is the smallest of VW and VH, and Vmax is the largest of the two. It's hard at first to know which units to pick, and you'll get better at it with practice. No one unit is better than the others, so pick the one that makes sense, and if you're arbitrarily picking values and guessing, chances are you're not using the correct units. Also try to avoid repetition. Instead of having a parent and child element both set to width 300 pix, you can set the child to width 100%. Specificity is a weight or value that browsers give to CSS selectors to determine which selector is more relevant or important, so that when two different selectors match the same thing, the browser knows which one to use. For example, a selector that uses an ID would be more specific than one that just matches a tag. Type or tag selectors are the least specific, then class selectors, ID selectors, and inline CSS being the most specific. Combining multiple selectors will also increase the specificity. For example, div ol li will be more specific than just li. CSS does not count how many elements it matches, meaning that a class might match more elements than a tag, but the class will still have higher specificity. And specificity isn't just a rough estimate sort of thing, there's an actual specificity score. Here's how you calculate it. Count how many IDs, classes, and tags the selector has. You don't add these up, the specificity score is just these 3 numbers. You can think of it as a 3-digit number, except each digit can be as big as you want. When you want to compare two selectors, just go from the left to right. If a selector has more IDs, it automatically wins, no matter how many classes or tags the other one has. If they have the same amount of IDs, you move on to the classes and compare those. If those are still equal, then look at the tags. If they are still equal, then choose whichever one comes later in the CSS file. Note that what this means is that the order of these don't actually matter, and neither does where in the document tree they are, meaning that in this example, body li and ul li actually have the same specificity. This seems to be a big misconception in CSS. Now there's a few more exceptions to specificity, so I'll encourage you to read the documentation on the screen at this link. A crucial part to understanding CSS is understanding the box model. All HTML elements are rectangles, or also called boxes. There's 2 main types of elements, inline and block. Inline elements are elements such as spans, and blocks are elements such as divs. But what does that mean exactly? To put it simply, block elements kind of break the flow of the page, adding new lines to the beginning and end of the elements. Their width is 100% of the container element, and its height fits the content. A lot of the elements that you think is inline are actually blocks. Elements like p and h1 and lists are actually blocks, not inline. This is why when you inspect these elements, they fill the entire width of the page. Inline elements do not break the flow of the text. They continue horizontally until it reaches the edge where they wrap to the next line. Their width and height are the same as the content and do not fill the width of the entire page. Elements such as span, em, strong, and even images are inline. Now let's look at each individual element. From the inside out, there's the content. Surrounding that, the padding, then the border, and finally the margin. You can think of the border as the kind of edge of the element, and the margin as the spacing outside of it, and padding as the spacing inside it. When setting width or height, by default, you'll change the sizes of content, excluding padding, border, and margin. This is why when you add padding, the size of an element grows, which is why when you make the width 100%, sometimes it overflows. You can fix this by setting the box sizing property to border box instead of content box, which is the default. Another interesting thing about the box model is that margins collapse. And what I mean by that is if you have two elements one under the other, both having a margin of 20 pixels for example, the spacing between the two isn't 40 pixels but 20. This is because the margins combine to form a single margin, which is why they're called collapsing margins. If two elements have different margins, one 30 pixels and the other 20 for example, the margin becomes the biggest of the two. And only vertical margins collapse, and horizontal ones don't. Why? Because I guess the CSS organization people said so. There's 5 different types of positioning: static, absolute, fixed, relative, and sticky. Static is the default positioning for HTML elements that are in the document flow and work like normal. Now, let's look at position absolute. When you apply this to an element, it is yoinked out of the document flow and the elements below move up, as if the element is no longer there. Because you set the position to be absolute, you unlock the few properties that you can set: top, left, bottom, and right. You can use these to move them around the page, but what are they relative to? By default, the corners of the page. But if the parent element also has the position property set, it will be positioned as a corner of the parent element. Fixed positioning works similarly to absolute, but this time it's fixed on the viewport, meaning that as you scroll, it still stays at the same position on the screen. It's very useful for things like navbars. Position relative is a bit more interesting. When you apply the property, nothing appears to happen, because it's still in the document flow. But you can use the top, left, bottom, right properties to offset the element. The final one is position sticky. It stays in the document flow just like position relative, but its top, bottom, left, and right properties are positioned relative to the nearest scrolling element. So when you scroll the page, it scrolls with everything else until it hits the edge of the element, where it begins to stick to the top. Position sticky doesn't mean it always stays on the screen. If the parent element scrolls out of view, the sticky element will do also. Although a web page is two-dimensional, you can think of it as being 3D and you are viewing it from the top. When you use positioning to move the elements, you might notice that the elements start to overlap. To decide which thing is on top of the other, z-index also becomes available, and you can set it to any number. But a little known thing about z-index is that it isn't global, meaning that you can have an element with a higher z-index but still be under another element. To give you an analogy, if you have ever used a photo editor or design software with layers, you can move a layer to the front or back. The software probably also has groups, or frames, or artboards, whatever it's called, to help you organize. Now, if an element is in one of these groups, it is essentially trapped and isolated from everything else. If the entire group is under a certain element, all the elements in that group will be also under that element, and can never escape. You can only decide which element is on top of the other within the group. The same thing happens with CSS, except that instead of calling it groups, it's called stacking contexts. Stacking contexts are created when you set the z-index of a container, but can also be created by setting other properties like position, transform, opacity, and a property called isolation, which is made exclusively for the purpose of creating stacking contexts. Now, if a child element has a z-index of 9999999, it will still never escape, and the high z-index will only mean that it is the topmost within the group. To give you an example, the yellow element has a z-index of 6, but it is still under the green element, which has a z-index of 5. This is because the parent element, the red container, has a z-index of 4, so none of the elements inside of that container can ever escape. It can never be greater than the z-index of 4. When you set the z-index of children elements, for example z-index 6, all that means is that it can be higher than elements within the group, meaning that the yellow element is higher than the blue element. So in this video, we went over 5 essential things that you need to know about CSS. There's a couple more interesting things, of course, but I hope these are a few examples of properties that are more complex than you think. And if you learned something from this video, then give it a like and subscribe. I'm Tony, and I will see you next time.